In example 1, we are going to compute a bunch of limits and function values for function f of x that is shown over here on the right by this graph. Part A, we want to find the limit as x approaches 1 of f of x. So this is this new notation, this new limit notation, and we need to remember what that means. So what are we trying to find when we are trying to find a limit as x approaches 1? We want to know what happens to the function values of f as x gets closer to 1 but isn't never really equal to 1. So we just want to know as x approaches 1 from the left and from the right, what do the function values do? And so looking at our graph, as x approaches 1, so gets closer to 1 from the left, our function values are all approaching 2. And from the right, they are also all approaching 2. So we are approaching 2 right here. And since the same thing is happening on the left and on the right, we can say that the limit as x approaches 1 of f of x is equal to 2. What happens at 1? So part B is asking us, what is f of 1? And f of 1, that is given by our closed circle right here. So f of 1 is equal to 3. Now let's look at what is happening when x approaches 3. So we're computing the limit as x approaches 3 from the left and from the right. So from the left, we are approaching minus 2, and from the right, we are also approaching minus 2. So the answer is minus 2. What is happening at x equals 3? So what is the function value? Well, there, again, the closed dot tells the story. So f of 3 is equal to 2. Part E is asking us what is happening as x approaches 4, but there's a little new piece in our notation, and that is this little minus sign right here. This little minus sign tells us that we are interested in what happens as x approaches 4 from the left. That's the meaning of that minus sign. Why does that mean from the left? Because we are looking for values that are 4 minus a little bit. That's how you can think about it. So 4 minus a little bit. Okay, so as we are approaching 4 from the left, values that are slightly less than 4, our function value approaches minus 1. And then what happens as we are approaching 4 from the right? That's what that little plus means. From the right. You can think about it as 4 plus a little bit. Okay, so values that are slightly bigger than 4 are approaching 1. So something different is happening around x equals 4, and that is what part G is getting at. The question is, does the limit as x approaches 4 of f of x exist? Well, our answer here is no. And why is it no? Well, it's no because the definition of the limit says a limit only exists if there is one value that our function approaches as x approaches 4. And over here, the limit from the left of f of x was equal to minus 1, and the limit as x approached 4 from the right of f of x was equal to positive 1. Those are not equal to each other. And so our the limit doesn't exist because the limit from the left and from the right are not equal to each other. We don't approach one value that we could call the limit.